Okay, so on this one, it wants to simplify the complex fraction. Now, what is this x to the minus 1, x to the minus 2? Remember, x to the minus 1 means 1 over x, and x to the minus 2 means 1 over x squared. Remember, negative powers are negative. They're like somebody that's negative at their job. They're unhappy at their job. They want to jump to a new job, then they're positive and happy. Well, that's a negative power, so they want to jump to the other side of the fraction, right? This x to the minus 2 jumps down the bottom. Then he's a positive 2 power. He's positive, he's happy on the other side of the fraction. So that's our first step here. Let me bring this down and do that on our first step. So this is going to be 3 plus. Now, the 30 is going to stay put. In other words, stay like this. Does that make sense? Because he's not unhappy. He doesn't have a negative 1 power on him. That's the common mistake a lot of people make, is they'll go, oh, okay, I got it, Mr. Heron. It jumps down, so I'll make this 1 over 30x. No. The 30 does not have a negative power on him. Only the x does. Only the x is unhappy. So it's like if your friend's happy at the job, but you're not, then you jump, but your friend's staying. The 30 stays regular in the top like that. Same thing on the bottom, right? The 100 doesn't have a negative power on him. Only the x to the minus 2, like that. Now, making sense? Only the item that specifically has the negative power on him is negative, unhappy, and jumps. Anything next to him just stays in the top. Okay, so that means we have a complex fraction. It's ugly. Fractions over fractions, right? We want to simplify that. It's just ugly. This happens all the time in engineering, physics, business, et cetera. When you do harder, more complex math things, economics, you get these complex fractions. And so you got to clean it up. We don't want that. It's ugly. We can make it simpler. How do we do it? Well, we've learned that sometimes you can just grab the fraction and flip it. Can you do that here? No, because of the adding and subtracting, right? I think you know that. So I went ahead and quickly answered that question. In the interest of time, you cannot flip added, subtracted items, right? Well, what do you do then? Instead, you multiply all the terms, and that's an important part of this puzzle. Oops. All the terms, top and bottom, by LCD over 1. And then what is the LCD? It's 1 of each type of item under a small bar. And it's the, for repeated items, well, let's just say same items. We'll repeat it. Is good. Okay. Repeated items to different powers take highest power. Right? So right here we have an x and an x squared. So I'm going to take the x squared. All right, so do you understand all those words? So first off, we cannot just grab this guy and flip it. We cannot flip added, subtracted items. Okay, so instead we multiply all the terms top and bottom by LCD over 1. But first off, what is the LCD? Well, it's 1 of each type of item that's under a small bar. So this x and this x squared, they're items under a small bar. What am I going to do? I'm going to multiply by x squared over 1, all the terms. Because when you have repeated items, like, we have x and x squared, you don't take them, you don't say, I'll take this one and this one. No. You only take 1 of each type. So notice if this was a y and this was x squared, yeah, then I would take them both because they would be different types. But when they're the same type, they're both just x. You don't take them both, right? You only take 1 of each type of item. Well, then what do you do when you have repeated items to different powers? You take the highest one. Take the x squared, not the x. And you don't total them. You don't go, oh, x and x squared, that's x cubed all together. No totaling. Just the highest. Take the highest. Okay. So x squared over 1, x squared over 1. There we go. And that's wrong. That's a very common mistake I see right there. I have not done what's true. What have I not done? Multiply what? All the terms top and bottom. So you got to do it over here also, and over here also. All the terms. You can't just do the fractions or something. Why? Because you have to do equal treatment top and bottom of the fraction. That way you don't change it. If you do the same thing to all the terms on the top and all the terms on the bottom, then the fraction won't change. You'll just clean it up, simplify it. All right. And so now we start canceling stuff. That's step 2. Down here. Now we're going to come down here and we're going to cross cancel all denoms. It's like bye-bye to all denominators. Okay. So x cancels here and leaves 1x on the top. This x squared and x squared wipe out completely. We good there? It's coming on down. What do we have in the next line? Well, let's take it piece by piece right here. This x squared, this 1 isn't doing anything. So it's just going to be 3x squared. The 1 on the bottom is useless. Same thing right here. These ones just go away. It's just x squared. Plus, minus, and what do we have? So this went right here. This went here. Okay, and then what's right here? 30x, right? And what's down here, right here? 100 cleanly. No x, right? See how here the x is totally canceled, so we just have the 100. Whereas on the top, this x canceled one of these 2 x's, right? Because x squared really means 2 x's. So one of them canceled one of them, but there's one left over, 30x, like that. Okay. Now what? Now what are we going to do? Well, now we have to factor the top. So we can't stop here. And can we cancel? Just cancel x squared and x squared. You know, I always say that. You guys know the answers. And you can't cancel these. You can't go, divide by 10. No. We cannot cancel. So we're on step number 3 here. We cannot cancel added, subtracted items, right? Instead, factor. So there's a lot that we cannot do with added, subtracted items. You've noticed by now you can't. In the beginning, we said you can't flip them. Added, subtracted items cannot be flipped. Instead, you multiply top and bottom. And now we've seen that you cannot cancel. You can't say, oh, cancel out. Cancel out. No, cannot cancel out. Instead, factor. Okay, so I'm going to factor. So how does it factor? Oops. Okay, I'm going to factor. So for factoring, you look at this guy and this guy. What do they have in common? 3x. Leaves x plus 10. Is that too quick? 3x times x, 3x squared. 3x times 10, 30x. See how I took out what they had in common on the top up there? Right? 3x squared and 30x. They both have in common 3x. 3 goes into 3 and 3 goes into 30. And they both have an x. Huh? On the bottom, what am I going to do on the bottom? I bet you recognize this one. This is a multiply. Multiply. The bottom doesn't have anything in common, but it's a multiply. X times x multiplies to be x squared. 10 times 10 multiplies to be 100. How do you get negative 100? 1 positive, 1 negative, right? Positive 10 and negative 10 make negative 100. Okay. And then what? X plus 10. Now we can cancel x plus 10, x plus 10 because they're multiplied items, right? Now they have parentheses around them and they're multiplied items, which means you can cancel them. You can't cancel added, subtracted items. You can cancel multiplied items. Okay. We are basically there then. That leaves 3x over x minus 10, right? That's all that's left. 3x on the top, x minus 10. Can I come in and cancel these x's? No, because this one on the bottom is an added, subtracted item. You cannot cancel added, subtracted items. You're just done. That's just, as Porky Pig says, that's all, folks, right there. That's the end of it. So what did we do? From the beginning, we did a lot of steps here. The negative powers flipped just the x's, because only the x's had the negative powers, to the bottom. Then we had this big complex fraction. And when you have that, you can't flip. When you add subtracted items, you multiply top and bottom by LCD over 1. LCD was the highest power. Of the stuff that was under the small bar. So x squared over 1, but all 4 terms. Then cross cancel and bring down the leftovers. We did that, and then we can't cancel, again, add subtracted items, so we factor the top, factor the bottom, cancel out, there we go. And much simpler. See how much simpler this is than the original ugly thing? So this is just much cleaner. And that's why we do it. Makes it easier to do the stuff we need to do in higher math and science with a cleaner version. There we go.